Okay, now how to build equations? The Kirchhoff first law and the Kirchhoff second law. How to build these equations? Okay. First of all, I already labeled. Okay. The first step I need to label. Okay, draw the circuit first. Draw the circuit first, and then I label all the EMF direction, negative to positive, and then I label all the current at the junction. You see, current at the junction, and also current at each resistor. And also current at each internal resistor. Then once I label all the current or the EMF direction, okay, then I'm good to go. All right. Basically, if you when you label the current, you see, the blue one is all current I1. You see that? Current I1. Okay, this I1, where is it come from? I want to ask you one simple question. This current I1, where does it come from? Is it come from battery E1? Is it battery E1 produce current I1? No. E1 is to drive or make the current I1 move, make the current I1 flow, provide energy. E1 provide energy for current I1 to flow. So actually I1 does not come from E1. I1 come from behind E1. You see that? I1 come from I1 come from behind the battery E1. You see, behind E1 is I1. I1 actually come from junction B. This I1 does not come from EMF1. This proves that battery is not the source of current. Battery is the source of energy to make the current flow. So current I1 does not come from E1. It comes from behind E1, behind the battery E1. You see, I1 comes from junction B. So from junction B, I1 going out and then passing through resistor 1, passing through battery. Battery E1 gives the current I1 energy. And then I1 go to junction A. You see that? And then junction I2 going out from this junction, passing through the battery E2, E2 give energy for current I2, then I2 go there, and then go here. Okay, you see the current I2. I can say that I2 is the same current. You cannot say the battery is the current source. You see, if this I2 is 10 ampere, before entering the battery is 10 ampere, going out also 10 ampere. The same current passing through the battery. It's just that the 10 ampere is we can say low energy. We can say low energy. But once it passed through the battery E2, it becomes high energy. It's just like the battery is like the water pump. You understand? Water pump to give energy for the current to pass through. We cannot say the battery is the current source. Oh, current going in the battery is only 10 ampere. Going out become different current already. Maybe become 20 ampere. Become 20 ampere. Ridiculous. Become 20 ampere. Oh, because the battery is a current source. My God. Yeah? Okay? Current that going in the battery is the same as current going out from the battery. Same current. It's just that current going into the battery is low energy or low potential. You can say low potential. Going out from the battery is with high potential or high energy. But the amount of current is the same. 10 ampere before, 10 ampere after. Okay? Enough of that. Just want to prove to you something about battery. Now, as usual, I1 coming up from junction B, entering junction A, and then I2 from junction A, passing through battery E2, and then passing R2, and then entering junction B. And then I3 going out from junction A, and then go down, passing through R3, and then passing through battery E3, and then entering junction B. You see, this is how the current This one all the same current. The blue one all the same current I1. The orange one all the same current I2. The pink one all same current I3. Okay. Now, I already finished labeling. Now, want to do the first law. First law, just pick one junction. You want the junction A or junction B? Both same. Both will give the same equation. So I just pick junction A. Junction A, what's the current going in? Current going in is I1 only. I1. So I1 lah. What's the current going out? Is the I2 and I3. Is the I2 plus I3. So I1 equal to I2 plus I3. So I got one equations. Okay, got one equations. Now I need to do the Kirchhoff second law. Kirchhoff second law, I need two equations. So I have three choices for me to choose. Three choices. Either I choose the upper loop, or bottom loop, or the big outside loop, So you have three choices. You just choose either two. You can choose the upper loop and the bottom loop, or you can choose the upper loop with the big loop, or you want to choose the bottom loop with the big loop. So just choose any. You will still get the same final answer. Remember, you still get the same final answer no matter which choices you make. Okay? In this case, I just choose the traditional one, upper loop and the bottom loop. I didn't choose the big loop. Okay? You can try yourself, choose the big loop and see you still get the same answer or not. Yeah? I'm sure, I can guarantee you will get the same answer with any choices you want to make. Okay? So the upper loop I put as loop 1. Okay, loop 1 means I travel from along this loop lah. That means I go from B, go to passing through resistor 1, passing internal resistor R1, E1, and then junction A, and then passing through EMF 2, R2, and then resistor R2, and then going back to the same point, junction B. Yeah, I can start from anywhere. I want to start from junction A, I want to start from junction B, I want to start in the middle here. I can start anywhere. I want to start from here also can. Yeah, it's as long as I complete a complete loop. As long as I must in a closed loop. I must have closed loop. I complete a loop. Understand? Okay. Now apply the EMF. The voltage supply must be equal to the voltage used by all the resistor, external resistor and internal resistor. Okay. Voltage supply equal to voltage loss. I can say voltage supply equal to voltage loss. So what is the voltage supply? So first of all, I look at how many battery are there. I have E1, I have E2. I label already. So label the direction of EMF from negative terminal to positive terminal. So now it's easy for me to find positive or negative EMF. Okay. So I can see, okay, the loop direction. Just now I talked about wise decision, isn't it? Wise decision. Try to follow the EMF and current so that you majority get the positive E and positive IR. Okay. So you see, I choose this loop direction anti-clockwise. Why I choose anti-clockwise? Because I try to follow the EMF E1. I try to follow the EMF E2. I try to follow the current I1 also. I try to follow the current I2. So later on, all I get here are positive value. Do you see that? This is what I want. This is called wise decision. If you choose, let's say, imagine, if you choose the anti-clockwise, what will happen? If you choose anti-clockwise, then you will surely get a negative E1, you get negative E2, you get negative I1 R1, you get negative I2 R2. But is that equation wrong? No. If you choose the anti-clockwise, loop, you get negative everything. Negative E1, negative E2, negative I1 R1, negative I2 R2, and so on. Is this equation wrong? No, it's not wrong. Because if you multiply negative 1 for both sides, you still get back all positive. You still get back the same equation, isn't it? So you don't be afraid. You want to choose anti-clockwise or clockwise, feel free to make your wise choice. Understand? Feel free. Okay. So now, let us first look at, I just choose the anti-clockwise. And let us look one by one where either is positive or negative. Okay. First look at total EMF. Total EMF, I have E1 and E2. Is this E1 same direction with the loop? E1 to the left, loop also to the left. So same direction. That's why positive E1. And then look at E2. E2 to the right, negative to positive to the right. The loop direction at the top here also to the right, same direction. So positive E2. Okay? Okay, now finish. No more battery. Now only left with resistor. We have R1 and R2 external resistor. We have internal resistor R1, internal resistor R2. So how to find? For resistor, we don't have terminal. If battery, we have terminal negative to positive. The battery depends on terminals, negative to positive, not depend on current, not depend on current. Battery depend on terminals, but resistor depend on current that pass through. Okay, look at here. This resistor one is current I1 pass through. You must also be careful what current passing through the resistor. Sometimes it's current I2, sometimes it's current I1. Sometimes it's current I2 passing through R1. So be careful of what current pass through. So you must label. That's why I say the first step is still the most important. Label the current correctly that passing through each resistor. Sometimes it is I2. Not necessary. R1 must be I1. R1 must be I1. No, it's not always I1. It can be I2. So the equation sometimes it can be I2 R1. Can be like that also. So if you don't make such a mistake that you use the wrong current. So to avoid such mistake, you must first label correctly. Label correctly what current actually passes through the resistor. Okay, label the correct current that passes through the resistor. Okay, so okay, never mind. That's it for the current just now. Okay, let us look at this R1. So the current passing through is I1. So this I1 is same direction with the loop direction. So positive I1 R1. And then for the resistor 2, the current passing through is I2. I2 same direction with the loop. So positive I2 R2. Okay. And then for the internal resistor R1. R1 is the current I1 passing through. This I1 same direction with the loop. So again, positive I1 R1. And then R2 is current I2 pass through. I2 same direction with the loop. So it's positive I2 R2. So this is the first equation. I got it. Okay. Then once you got this, and you substitute all the values. All the values given. And then I need another last equation, which I choose the bottom loop lah. I choose the bottom loop. Okay. So which direction I choose the loop? The bottom loop I choose clockwise or anti-clockwise. Okay. If I look at here, if I choose clockwise, the top one will be same direction, current also same direction, but the bottom one, the current become opposite direction. EMF also opposite direction. So no choice. This is when the opposite direction means negative EMF. This is the like opposite pump, opposite water pump, which go against the current. Go against the. It doesn't help. It doesn't work together. It go against. So, but never mind. I choose clockwise because majority is follow the direction. Only some opposite direction. So I just choose clockwise lah. Or you want to choose anti-clockwise also can. You want to choose anti-clockwise also can. But now this one I just choose clockwise. So now total EMF. I have E2 and E3. Okay, E2 same direction with the loop. So it's positive E2. And then for the E3 is opposite. You see that? E3 is to the right, negative to positive to the right, but the loop is to the left. So opposite. So you get negative E3. Okay? Negative E3. Now, that's about EMF. How about the resistor? Now, resistor, I have R2, R3 external. I have R2, R3 internal. Okay? Let's look at the R2 external. R2 is I2 passing through. I2 same direction with the loop. so positive. Okay, positive I2 R2. And then for the R3 is the current I3 passing through. I3, resistor look at current, battery look at terminals. Resistor look at current. So the current I3 passing through resistor 3, this current I3 is opposite to the loop. Opposite to the loop, so negative I3 R3. Negative I3 R3. Okay. So and then for the internal resistor R2, we look at the current passing through is I2. I2 same direction of the loop, so positive I2 R2. Okay. And then for the internal resistor R3 is the current I3 passing through. I3 opposite to the loop. You see, this I3 opposite to the loop. So it's negative I3 R3. So that's how you get these equations. So I got the third equations. So later on, I have these three equations. Normally you are dealing with three unknowns. Normally you deal with three unknowns. That's why you need three equations. Three equations to solve. That's why you need to build three equations. One equation from the Kirchhoff first law, current in, current out. Two equations from the Kirchhoff second law, total E equal to total IR. Once you have these three equations, you just solve using scientific calculator. That is I will explain in the problem solving part. Yeah, how to solve using the scientific calculator. I arrange by sequence I1, I2, I3, and then equal to what number? Below also I1, I2, I3. I1, I2. Sometimes I don't have the I3. I just put 0, I3. Something like that. Yeah, and then the third equation is let's say I don't have the I2. I just put 0, I2, and then I3. Yeah, it have values here. Yeah, it has values here. Maybe it's 2I2. Maybe 3I. Just arrange in sequence, and this is the number. Yeah, behind here is a number. Let's say number 4. So I arrange it, and then I solve using the scientific calculator. You choose the in the calculator you can choose something like AX plus BY plus CZ equal to D. You understand? Then you punch in the solve three unknowns, solve equation. This is the function equations, and then you need to key in A1, B1, C1, D1, A2, B2, C2, D2, and then so on. Then you solve it. Yeah, you solve it. This is called the matrix method. Yeah. That is called solved by scientific calculator. I will explain this more. And then sometimes the current you get negative value. In the end, sometimes you get current equal to positive 0.7523, and then you get ampere, and then I2 suddenly you get negative 0.438 ampere, and then I3 is you get positive 0.223. Yeah. This one you suddenly get negative value. What does it mean? A negative value means that a negative value. Let's say I2. Let's say for this case, I get the current I2 is negative current. What does it mean? It means that the current I2, the actual current direction is opposite to the direction drawn. So that means I can write over here. That means I can just say the actual is actually the opposite direction. The actual current direction. The actual current direction is actually opposite. The actual current direction is actually opposite to the direction drawn. That means current I2, let's say initially I2 is to the right. I2 is to the right, but I got the current is negative value. Negative value means the actual current should actually to the left. I2 actually is to the left. This is the actual direction. The one in the diagram is the direction drawn. You understand? Direction drawn. So the negative current means the actual current. I2 negative value means the actual current is opposite to the current drawn is opposite to the current drawn. So which means that the current drawn is actually in the wrong direction. The actual current is the correct one. You understand? Actually, is to the left, not to the right. Okay? The actual current is to the left. But I want to tell you that if you got a negative current already, don't go to change your diagram. Don't go to change your diagram and you go to rub the direction drawn, rub it, and then you draw the actual current there. No, because our answer depend on your diagram drawn. It's based on your diagram drawn. It's based on your wrong current drawn, wrong direction. So if you change to the actual one, then the examiner become confused already. If the actual is to if the current you draw is to the left, then the negative means is opposite. Is the correct one is to the right. So the examiner will get wrong idea. So once you drawn like that, just leave it. Don't do anything. Don't go to correct your diagram. Don't go to correct your diagram. Even though your current direction is actually wrong, but never mind. Because the final answer negative value already show the actual direction. Yeah, you just write comments here. You just write in the bracket comment here. The actual current is actually opposite to the one you draw. Okay, and the examiner will understand. The actual direction is actually to the left. Okay, so don't go to change your diagram. Don't go to change your diagram. The examiner will get a wrong idea, will confuse. Okay, so that's all for Kirchhoff law. Okay, thank you for watching, and next video please.